We have done with basic terminologies and also the definition. Okay, how many types of differential equation that you have learned? Anyone? How many types? All right, 2. What are the types? The first one is what? Ordinary, and another one is
Partial.
partial. So how can we determine the order of the differential equation?
Determined by the highest derivative.
Okay, good. So you just have to take a look at the highest derivative, and that is the order of the differential equation. Okay, so now as for today, we're going to proceed with first order ordinary differential equation. So from the notes, right? So I believe all of you got the notes already. So from the notes, as you can see here, there are 5 types of first order differential equation. So actually there are many types, but we just focus on these 5 for your syllabus. There are 5 types of first order ordinary differential equation: separable equation, homogeneous, exact, linear, and Bernoulli. So let's start with this separable equation first. Okay, so how can we identify this separable equation? So, inseparable equation, it means that it can be separated basically based on a variable. So now we have, suppose we have function of x and y. Okay, the function is in terms of x and y. All right, where it is dy dx. So the function should be a combination function of x and y. So this function can be a separable equation if we can separate them coefficiently based on each variable. So if you can separate y with y and x with x, it can be separated. So it is separable equation. So how can we find the solution? We just integrate both sides according to the variable. So let's take a look at the examples here. Now, solve the initial value problem. So this is differential equation. Of course, you know that this is the differential equation. So now this dy dx is in terms of y and x. So first, you should check whether can this function be separated or not according to the variable. So now you have to separate y variable with dy, x variable with dx. So it can be written just like this. So this is y over 1 plus 2y. As you can see, so just separate y with dy, x with dx. So this one, just put it to the left hand side. So what should you get? Okay? Got it?
Yeah.
So now, as you can see, it is separated according to y here with dy x here with the x. A function of y is together with dy. A function of x is together with the x. Now, it is separated, so you can find the solution by integrating both sides of equation. So you just integrate both sides. This one integrate with respect to y. This one integrate with respect to x. Okay? Clear? So this one you just can separate. Okay, integrate 1 over y, you should have. And y, this one becomes y squared. This one becomes sine x plus. Okay. Got it? So this is what we call general solution. Because we still have a constant there. So you are given a condition. Just apply the condition. This is initial condition. So when x equals to 0, y equals to 1. So just substitute. Sorry. Then your particular solution is ln y plus y squared equals to sine x plus 1. Once you've obtained the value of c, just substitute back to your general solution. Okay, clear everyone?
Yes, sir.
Anyone has question? No question? Understand it all? Okay, so let's take a look at the notes. The remark there, some DE may not appear separable initially, but through appropriate substitution, the DE can be separable. Okay. So this one is from the note. Some differential equation may not appear separable at first, but through appropriate substitution, the DE can be separable. Okay. All right. Before we proceed with the non-separable form, why don't we try to just separate the function, not finding the solution. You know how to find the solution, right? Once you separate the function according to the variable, then you just integrate both sides. Okay? Once you integrate both sides,
Excuse me, doctor.
yes.
When you integrate the 2y square, we're supposed to get 2y cubic over 3, not y square again.
Which part? This one?
Yes, after separating, you wrote 2y, not 2y square.
Because I just simplify this with y. Here, this one is 1 over y. This one is 2y squared over y become 2y.
Oh, I get it.
Okay? All right. Okay, why don't you try to separate this first? Okay, I like to ask for volunteer just, okay, yeah, we can just pick this randomly. We try to separate A, D, and B. Okay. Anyone want to try? Just separate this. Anyone? Just separate this. Just voice out the answer. No need to write down. Okay.
For A, I got 1 over secant square y dy equals to 1 over 1 plus x squared dx.
Right. 1 over secant squared y dy equals to 1 over 1 plus x squared. Yeah. So once you separate the function, then you just can integrate both sides. Okay, what about B? We have V there.
May I try, Doctor, for B?
Okay.
For B, 3v over 1 minus 4v square
Okay,
equals to
3V
1 over x dx.
equals to 1 over
1
x
over
dx.
x dx.
All right, good. Okay, the next one. This is quite easy, right? Let's choose the harder one after this. All right, the last one.
The last one, 1 over 1 plus y square dy equals to 3x square dx.
Okay. All right, so basically this is quite easy. Once you know how to separate, so it is easy for you to integrate. So just like this one, let's say for this one, you have to rearrange first, put x together, and then you just can separate. Apply to the t and f also. Okay, put the variable first together before you separate, and then you can see the process is quite easy, because this one is only separated between fraction, so it is easy for you to just separate. But if you have addition and subtraction, you should accumulate first the variable, and then after that you separate. Okay, so now let's try to solve the non-separable equation, but with some substitution it can be separated. Okay, let's take a look at the next example, which is example 2. Okay, show that the differential equation, can you see it or is it too small?
Can see that.
Okay, show that the differential equation dy dx equals to x plus y squared can be reduced to a separable equation by using substitution z equals to x plus y. Then obtain the solution. Okay, as you can see here, that the function dy dx equals to x plus y squared cannot be separated. X and y are together here bounded with the power of 2 then. So now we have to separate this by using substitution given. So how can we find the separable equation by using z equals to x plus y? Okay, now given z equals to x plus y. So differentiate this z. We have dz dx. Differentiate with respect to x. Because here x is dependent, here x is dependent, so we just want to make this x independent. Dx here, from the dy dx here, x is independent, so we want to make x here independent also. So we differentiate z with respect to x. So from z equals to x plus y, we have dz dx equals to 1 plus dy dx, because we want to create the dy dx in order to substitute here. So now from here, you know that dy dx equals to dz dx minus 1. So substitute here, dy dx equals to dz dx minus 1. Right? X plus y squared equals to z squared, because z is x plus 1. This one is z. Okay, now you can see here the differential equation now is in terms of x and z. So can this function be separated or not? Can you separate this?
Yes.
So what is the separated version?
1 over z squared plus 1 dz equals to dx.
Okay, equals to x. Okay, try to integrate this both sides. What should you get? Integrate 1 over z squared plus 1 with respect to z equals to integrate 1 with respect to x. What should you get?
Ln z squared plus 1 equals to x plus c.
No, try again. Okay, anyone? right? Thank you, Haris. Arctan Z. So you should have inverse tangent of Z. Okay, integrate 1 over Z square plus 1 is inverse tangent of Z. Integrate 1 is X. Then don't forget to plus with C. Okay, so now this is the solution in terms of Z. And remember, the original problem should be in terms of X plus Y. So you just substitute back. What is Z? Z given by X plus Y. Okay, so X plus Y here equals to tangent X plus C. Right, where if you want to simplify up until Y, we can write Y equals to tangent X plus C minus X. Okay, if it is doable to simplify up until Y, then you can simplify. But from the previous example, it is quite complicated for Y ln Y plus Y squared. So just leave it there. As long as we have Y something equals to X something. Okay. Any question for this example? Okay, so let's proceed. We have done with separable. Okay, why don't you try the first activity there? Okay, let me choose the question. Okay, try the first one. Equation partial. Try this one. Solve the following initial value problem by using the method of separation of variables. Okay, try it. Try this one. I give you around 3 minutes. The answer is if you have question, please do ask. All right. Got it? Oh, we only have 41 participants today out of 59. Okay, guys, can you do this? Anyone has problems? Okay, dapat. Bagus. All right, good job. Okay, so I believe if some of you got the answer, so maybe the rest of you will get the answer. If you have problem, you can ask your friend. All right, so that is the process on how to find the solution of differential equation for separable equation. Okay, so let's take a look at the next type. Okay, at least we have done with 2 types today. We have 5 types. Okay. The next type is homogeneous equation. Okay. Homogeneous equation. So first thing first, you have to know that function is homogeneous. So how can you identify the differential function is homogeneous or not? Okay. How to identify? So we have dy dx, which is a function of x and y. Okay. We have dy dx, which is a function of x and y. Then this function is homogeneous if f lambda x lambda y equals to fxy. If we substitute x here, with lambda x and y here with lambda y, and you do some simplification process, and if you get fxy back, then we call it as homogeneous. Okay, then we call the function as homogeneous. Okay. So how can we show that? Okay, let's try. Okay, let's try. How can we show the function is homogeneous or not? Okay, let's try A. Determine whether the DE is homogeneous or not. So you know that the dy dx here is represented by fxy. So fxy is actually equals to x squared plus y squared over x minus y, x plus 1. Now, in order to show whether this function is homogeneous, you have to show that f lambda x lambda y equals to fxy. So, what is f lambda x lambda y? So, f lambda x lambda y, you just substitute x with lambda x, y with lambda y. So, now the function will become lambda x squared plus lambda y squared over lambda x minus lambda y, lambda x plus lambda y. And then you have to simplify. So here we have lambda squared, x squared plus lambda squared, y squared. Here you just can factorize. And then you just can simplify here. This one lambda become lambda squared. Then you just can omit the lambda squared. So this is equals to fx. Okay, now when f lambda x lambda y equals to fxy, then what we call? We call it as homogeneous. So this function is homogeneous equation. Okay, understand? Okay, try to prove B. Is it homogeneous or not? Just substitute x with lambda x, y with lambda y, and then you simplify. you can get or not fxy back. If you cannot get the fxy back, then it means the function is non-homogeneous. All right, clear everyone? All right. What is your answer? Is it homogeneous or non-homogeneous? Can you prove it? Done? You know how to do this? Hello? Are you okay? Yes, it is non-homogeneous. Okay, so for this case, in order for you to just substitute lambda x, lambda y, it is easy for you to simplify first. Okay, let's try. It's quite easy. Just put y over x there. Okay, put y to the right hand side and then divide everything with x. So there is no x there. And then this is your fxy. This is your fxy. So just substitute f lambda x, lambda y in your fxy. So this is lambda. Lambda can just only eliminate, and this one become okay. So we have here y over x plus lambda squared third lambda x squared. So we still have lambda then, okay? Then it is not equals to fxy. So this is non-homogeneous equation. Okay, clear? So anyone has question on how to prove the function is homogeneous or not? No question? Okay, now how can we solve the homogeneous equation? That is how we prove those lambda part on proving only. Okay, so how can we solve? Okay, so first, you should determine whether the equation is homogeneous or not. So we have done with the part. And then we need to use substitution of y equals to vx. Okay, and dy dx equals to v plus x dv dx. Separate the variable x and v, integrate both sides, use initial condition. So this is the substitution that you need to use. Remember, if the function is not separable, we can use a substitution. So for this homogeneous equation, it is non-separable equation. So we use substitution, which is given y equals to vx here. Then we just substitute y equals to vx, and then we differentiate this by using product rule. We have dy dx equals to v plus x dv dx. This is by using product rule. So this dy dx is actually obtained from y equals to vx. Same. All right. Okay, try example. We want to find the solution of the homogeneous equation. How can we solve this? Solve the homogeneous equation y squared plus xy dx minus x squared dy. Okay. Can we just skip the step of showing it is homogeneous, because it shows that solve the homogeneous equation. So you just know that this is homogeneous, then you just find the solution of this homogeneous. If you are asked to show whether the function is homogeneous or not, then you need to show. So how can you show? F lambda x, F lambda y equals to xy. So now this is stated. Homogeneous equation here is stated, so no need to show. You know how to show already, right? So how can we solve this? Okay, so since it is stated that the equation is homogeneous, no need to show, then we directly use, remember, for homogeneous equation, we use substitution y equals to vx here. And dy dx equals to v plus x dv dx. Okay. So we have to use a substitution of y equals to vx, and differentiate this, you get dy dx v plus x dv dx. Alright? So simplify this first. From here, what is your dy dx? Just put this one to the right hand side first, and then dy dx equals to y squared plus xy over x squared. Okay, clear? We have, let me check. Okay, then dy over dx is y squared plus xy over x squared. Okay, now you have your dy dx. Then just substitute your dy dx with v plus x dv dx. And y is vx, so v squared x squared. Okay, and x is x, y is vx over x squared. So simplify this first. Simplify this, you get what? This one is v squared. This one is v squared x squared. Just separate this, factorize. Right? So we have v plus x dv dx now equals to v squared plus v. So x dv dx equals to v squared plus v minus v. So we have v squared only. And then once you substitute, what you need to do, separate the variable x and v, integrate both sides. So this is the process of solving a separable equation. So you just separate these two. It is separable, right? Where you just can separate v with dv and x with dx. Okay, clear? Can you proceed with the integration step here? What should you get? All right, integrate this. Okay, anyone want to try?
Negative 1 over v equals to ln x plus c.
Equals to ln x plus c. All right, good, thank you. Okay, so this is what we call the general solution in terms of x and v. So back to the original problem, you have in terms of x and y. And there is no condition given, so just let it see that. So we need to substitute back. Since y equals to vx, then v equals to y over x. So substitute back. What is v? So here you should have minus x over y equals to ln x plus c, and hence y equals to minus 1 over x ln x plus c. Okay, clear? This is how you solve homogeneous equation. And as you can see, there is not much difference between separable and homogeneous. Just we have to use substitution first. And then once you substitute and simplify, as you can see, it is separable equation. So solving this separable equation, you just separate the variable and then integrate both sides. Okay, clear? Anyone has question? Okay, clear, good. Okay, look at the notes there. Non-homogeneous can also be reduced to homogeneous by using the right substitution. Again, same like the separable equation. If you got non-homogeneous, you can reduce to homogeneous first by using the right substitution, and then you can solve it. Okay, let's try last example for today. Okay, find the solution for this non-homogeneous. It is stated that this is non-homogeneous. So what you need to do is to use the substitution given in order to reduce this non-homogeneous to homogeneous first. Okay, and then once you want to find the solution of homogeneous, again, there is substitution that you have to use. Okay, let's do it slowly one by one. Okay, find the solution of this non-homogeneous by using the following substitution. So as you can see, you are given the substitution of x equals to x plus 3 and y equals to y plus 2. Okay, so from here, if you differentiate this x with respect to the big X there, you will obtain what? 1. Same to this one. This one also equals to 1. Then dx equals to x, dy equals to 5. Okay, so actually this is just showing different variable. So this is the big X here. Okay, now just substitute here. Dy is dy, dx is dx, equals to y. Y equals to what? Y equals to y plus 2 minus 2. X equals to x plus 3. Y is y plus 2 minus 5. So your dy dx equals to y 3 plus 2 minus 5. So x plus 5. Okay, so this is how you reduce from non-homogeneous to homogeneous. If you check, this is homogeneous already. Okay, now proceed with what? Proceed with homogeneous substitution, where you have to use v equals to y equals to bx and d by dx equals to v plus x dv dx. Okay, understand or not? So substitute here. So d by dx now becomes v plus x dv dx equals to y is vx, x plus vx. Alright, okay, simplify this. What should you get? X dv dx equals to this one x, this one x, this one x. So this one can be simplify v1 plus v, right? So v over 1 plus v minus v3. Okay, will give you yes 1 over v, 1 over v. All right, can you separate this equation now? Is it separable? Y minus xy become y. Which part? Which part? Which part? X minus x over y. The previous one. For example, 1 minus x over y become y. Okay, just this one. I just move to the right hand side. So y this is y, right? This is y. 1 over y, right? 1 over y. Okay, sorry. 1 over y, right? Am I right? Right. There's a correction there. Okay. Thank you. Okay, so let's proceed with this. So now it is separable. Can you separate this? Can you integrate this? So just separate this. Become 1 plus v. If you want to remain the negative, it also can. So just separate this and then integrate 1 by 1. Okay, what should you get here?
We should get negative 1 over v plus ln v equals to negative ln x plus c.
All right, good. Okay, so this one negative 1 over v plus ln v equals to minus ln x plus c. Okay. So you can simplify this. ln together. C plus 1 over V. This is ln Vx. E to the power of C is A, E 1 over V. Alright, so remember what is V? V is Y over X. X over Y. So Y equals to AEX over Y. Okay, but this is big X and big Y. Remember, your X and Y is a substitution from here. So X is actually equals to X minus 3, Y equals to Y minus 2. So substitute back here. Y equals to AEX over Y now becomes Y minus 2 AEX minus 3 over Y minus 2. So Y equals to AEX minus 3 over Y minus 2 plus 2. So this is how you find the solution. Okay, any question?
Doctor, I got a question.
All right.
For x dv over dx equals to negative b square over 1 plus b. If I bring along the negative sign to the left hand side, is it okay?
No problem.
No problem.
Uh,
So I will also get the same answer.
Negative. Maybe in terms of sign. You can
Oh,
check. Okay, you can check. I put the negative with x because 1 over x is simpler compared to 1 over v squared. Okay, we want to avoid complicated process. Okay, but if you just take along the negative with v, it doesn't matter. It should be right too. Okay, there is nothing wrong there.
okay. Thank you, doctor.
Okay, but you need to be very careful here. Okay, but for this case, the variable used is big X and big Y is quite confusing, right? But if you want to try it again, you just can change the variable there. All right, but this is how we do it. For non-homogeneous, first we substitute to reduce to homogeneous. Once it is homogeneous, again, we substitute the homogeneous substitution for us to find the solution. So there is 2 substitution process here. That's why it's quite long. But do you understand? That's the objective. You have to understand and you know how to do it. Then whatever question it is, then you can do it. Okay, clear everyone? From 1 to 10, where are you? Range yourself from 1 to 10 for separable equation and homogeneous.
Seven.
Okay, 7. Next 6. Right? We have learned 2 methods today. Separable and homogeneous. What about the rest of you? 6, 7, 8. It's okay. If you just got 1, that's good. Okay. Because there's still a value, right? It's not 0 at all. Okay. Right. So for more exercise, you just can refer to the tutorial given. There is the answer there. Okay. Up until now, you just can proceed with tutorial number 1. and number 3. Number 1 and number 3. Okay, anyone has question before we stop?